Okay, do you see the screen now, the beam?
Yes.
Okay. So the question here will be to draw the shear and bending moment diagrams for the following beam. Okay. So first, what will be the first step that we discussed yesterday, last time together? What should we do first
Find
in order to be able to
external
draw the shear? Yes,
find
very good.
external
The first
forces.
step is, yes, very good. So the first step will be to find the external forces. So here we have, this is the symbol of a pin. So we have two possible reactions, Bx and By. So I have here Bx and By. And I have a roller at F, but if you look at your the roller at F, so this is Y and this is X. If you look at the roller here is from the upper part. So it was a contact line is here. So how will be the force Fy?
Downward.
Downward. Fy will be downward. Great. Okay. So now what we will do is that we will calculate these forces. To find these forces, we have to write three equations. First, along x, we don't have any force. So sum of x equals to 0. So the first equation will be sum of x equals to 0. And then we deduce that bx is 0 because we only have bx force along x direction. Now, second equation, we can use several strategies to find By and Fy. You can apply or one force equation, one moment equation, or two moments equation. Okay, let us try together and we can make verification by using three equations. So if I write first sum of moments about F equal to 0. To be able to find the total moment about F, what should I do with the distributed load?
One
So I have here, yes,
concentrated force.
exactly. So here in this problem, if I look at the load, what do I have? I have a couple moment, a clockwise couple moment at A. I have a concentrated force at point D of 10 kilonewton. And I have, for my distributed load, I have a rectangle and a triangle. For the rectangular load, I can replace it by a force of magnitude equal to what? To the area of this rectangle. The area of this rectangle is 4 kilonewton per meter times the length, which is 4 meters. So in total, this area rectangle equals 4 times 4 equals to 16. And since we know that we can replace a distributed load by a force passing by its centroid, the centroid of the rectangle is along this line. So I can put that in addition to the 10 kilonewton at D, I have the effect of the rectangular force. So I can put here, in addition to 10 kilonewton, I have 16 kilonewton upward. And now for my triangle, same procedure. I calculate the area. The area of my triangle is 4 times 3 over 2. So here, area, this is area 1. Area 2 is equal to 4 times 3 over 2, which is equal to 6 kilonewton. And concerning the location, For a triangle, we know that the centroid is at 1/3 of the height from the base and at 2/3 from the extreme point here. So if this length is 3 meters, the centroid is at 2/3 of this length from the extreme point. So this distance is 2/3 times 3 equals to 2 meters. And this distance from the centroid to the base is 1 meter. So if I want to replace the triangular load by one concentrated force, it should pass by this level. Okay, so this is my triangular force equal to 6 kilonewton. Now I am ready to get my external reactions. If I do sum of moment about F equal to 0, I should take a positive direction. If I consider the clockwise as positive, I have first, when I do sum of moment, a couple moment is a free vector. I should account for it at any point when I do sum of moment about any point. So I have first the couple 2 kilonewton meter plus 2. Now, for my by is at a distance of f. This is the perpendicular distance from by to f. So it's 1 plus 2 plus 2, 5 plus 3, 8. So I have to do, and it's rotating, by is rotating about f in the clockwise direction, plus by times 8. Now, for my rectangular load, I have 16 kilonewton at a distance of 5 meters from F. So, plus 5 times. Now, if you want, because the 16 kilonewton force and the 10 kilonewton force are both at 5 meters from F, you can add them. And in total, it's 10 times 5 plus 16 times 5. So 5 times 26. And finally, for my triangular load, the distance is 2 meters from F. So plus 2 times 6 equals to 0. The only unknown in this equation is by. Okay, so I can solve for the value of by. Now, if we do our calculation,
minus 18.
doing our calculation, we find out that by is 18 kilonewton. Okay, so by we solve for now.
Minus 18 or 18?
By, yes, minus 18, of course. Minus 18, because here we have, so minus 18 kilonewton. This means that by is in the opposite direction. Okay, so I assume that by is up. Since I obtained a negative result, so by is downward. Okay, so here, if you want, you can update this. You can say, or you can keep it like this. You can keep by upward, but when you replace in any other equation, you replace by minus 18 kilonewton. Okay, so now we can now do sum of forces along y. The only unknown will be Fy. Okay, so now if we do sum Fy equals to 0, what do we have along y direction? We have plus by. I put the plus because I considered by to be upward. Okay, So
Doctor,
yes.
and sum of moment
Yes,
about
tell me.
F.
Yes.
What is 5 times 26? Can you please repeat?
Yes. The rectangular load 16 is replaced by 16 kilonewton here at point D. Okay? And at point D, you also have a concentrated force of 10 kilonewton. So what is the total force acting at D? 16 plus 10, 26. And this
26.
force is at a distance of 5 meters from F, so we multiply by 5.
Okay, thank you.
So now, welcome. Let me, because we, let me put it again. Now, if I want to write sum of, so again, if I put my forces, so By is, I assumed it to be up, but I got as value, you can write here that By is minus 18, okay? And now if you apply sum of y equals to 0, what do we have? We have, since I didn't change the direction here, it's always up. And if I consider the upward direction as positive, I will put plus By. But when I replace, I will put instead of By minus 18. Yani, or you put here plus By and you replace by minus 18. Or if you want, you can fix your force. And you can say, since I got negative result, you can fix your arrow here and put it downward. And then you put directly minus 18 kilonewton because it's downward. And in both cases, you'll get exactly the same result because here you will replace By by minus 80. Okay? Now, what do we have as forces? We said that we have here the 10 plus 16 for the rectangular load, so plus 26. And we said that we have here for the triangle a force of 6 kilonewton, so plus 6. And since we know that Fy should be down because the roller will do a force perpendicular to contact from roller towards the surface, so it's minus Fy equals to 0. Okay, so now all we get Fy. Fy is 32 minus 18. Okay, so it's equal to 14. So Fy is equal to 14 kilonewton. Okay, now if you want to verify your result, so here you put 14. Since we got a positive result, this means that Fy is really downward. Okay, now to verify your result, you can use an additional equation. You did already sum of y, you did sum of moment about f. You can verify that sum of moment about b should be 0. If you get 0, this means that your calculation is right. If you sum of moments about b, what do you have? So if we write sum of moments about b equals to 0. If I consider the clockwise direction as positive, I have first the couple moment here, which is a free moment. I should put it, if I do sum of moment about any point, I should put it. So I'm doing now about B, I should put it. It's plus 2. Now, By is passing by B, no moment. Concerning the forces here, the concentrated force and the triangular load, both act at D, and the total here, as we said, is 10 plus 16, 26. This force is located at a distance of 3 meters from B, 2 plus 1. So this is 3 meters. And it's rotating about B counterclockwise. So minus 26 times 3. Okay. And you have for the triangular load, it's 6 kilonewtons. The distance from B is the following. So I should consider this distance from B to the point of application of the triangular load force. We said that this triangular load force is at 1/3 of 3 meters from the base. So this is 1 meter. So you have here 1 and here plus 2, 3, plus 2, 5, plus 1, 6. Okay, so in total, this force is at a distance of 6 meters from B, and it's rotating counterclockwise, so minus 6 times 6. And finally, the final force is Fy. We want to verify that this force, the calculation is true. So if we do the moment of this force is clockwise about B. So we should put plus 14 times the total distance from B to F. The total distance from B to F is 1 plus 2, 3 plus 2, 5 plus 3, 8. Okay, so plus times 8. If you do on your calculator this, you should get 0. If you don't get 0, this means that you have a calculation error in Fy. So we will get 0 verified. This means that we were able to exactly compute our reactions. So we are done now with the first step, which is the calculation of reactions. We can move to the second step. Okay. Next step, we will draw the shear and bending moment diagrams. Okay. Let us do it together. So this is my beam, and I want to draw the shear diagram first. Okay. So to draw the shear diagram, as we said in class, we should look at the beam. We should look at the load on the beam, because the distributed load represents the derivative of shear. Okay, and we said that if we have a concentrated force, this will lead to a jump in shear. Let us start together. How we explain the different steps? We start from the beginning at point A. Okay, just before point A, we don't have anything. This means that shear was 0. Now, between A and B, do we have any force distributed or concentrated? No. This means that at A, what will be the value of shear? So you can write the following as explanation.
0.
Okay, let us write. Yes, 0, exactly. You will say, so first you will write V at A. Let me write it in bigger format. So V at A is equal to 0. What is the reason? Because no force at A. Okay? No concentrated
دكتور
force. Yes.
نحن على كل بوينت بدنا نعمل شير.
نحن بدنا نلاقي على كل البيم الشير. Yes. Because we want to draw the shear and bending moment diagrams for this beam. Okay?
Okay.
So first, at A, there is A equals 0 because no concentrated force at A. Now, between A and B, do we have any load?
No.
Okay, so we say between A and B, no load. So, okay, VA, so V is constant equal to what? To 0. So V is constant between these 2 points equal to 0. Now, what will happen at B? If you want for B, suddenly, what do we have at B?
Downward jump.
Downward jump, very good. Because at B, we got that, now we can put the actual direction. We have 18 kilonewton downward at B. And we have at F a force of downward of 14 kilonewton. Okay, so now we can say that point B, at B we have a jump. That's why, if you want, whenever you have a jump at a point, you take the point just after you name it B minus, and the point just before B minus, and just after B plus. Okay, so now what can we say? We can say between A and B minus, no load. So V is constant equal to 0. So VA equals VB minus equals to 0. Now what will happen at B? As you said, at B we have a concentrated force. So at B we have concentrated force. So we'll have a jump, as you said. Okay, and how to find the value at B plus? We just say delta V at B, delta V, which is the change of shear at point B, is equal to the shear at point B plus minus the shear at point B minus. And since we have a downward force, then delta, the jump, is negative. So minus 18. Okay? And since VB minus is 0, so what do we deduce? We deduce that VB plus is equal to minus 18. And now if you want to annotate together to not forget these values, we have VA 0, VB minus 0, and VB plus minus 18. Okay? Now, from B to C, no load. Okay? So now we can say from B to C exactly as between A and B minus, no load. Since from B to C no load, so the shear will remain constant. Okay? So we can say that VB plus equals to VC. So we'll have a minus 18 until point C, the value will remain minus 18. Now, what will happen between C and D? So now between C and D, to justify what is happening, we say we have a rectangular load. So between C and D, we have a rectangular load. So W is constant, okay? W is constant, equals to, what is the value here? Because you have upward distributed load, so plus 4. Plus 4. When W is V is linear, because omega is the slope of, or W is the slope of V. Okay, so since omega equals to derivative of shear with respect to x, because omega is constant, V will be linear, so V is linear, and since omega positive, V will be increasing. So it will increase in a linear way between points C and D. Okay, now what should we do now? We should say that at point D, what do we have? We have a concentrated force. So we should take D minus and D plus. And here we should say between C and D minus, okay, omega is constant. Now at D, what will happen? We'll have a jump of 10 kilonewton upward, because we have an upward force of 10 kilonewton. So now, before talking about the jump, what should we do? We should find the shear at D minus. Can you tell me how to find the shear at D minus? What can we write? What is delta V? What is the change in shear, okay, between points C and D minus? Who can tell me?
VD minus VC.
Okay, equals to what? How we calculate this delta V? It's the area, okay? It's the area limited by the distributed load. And since W is positive up, يعني delta V is plus area 1. And what is area 1? This is area 1, limited by the rectangle. Before point D. Area 1 is the height here, which is 4 kilonewton per meter, times the length between C and D, which is 2 meters. So area 1 is equal to 4 times 2 equals to 8. So what do we deduce? We deduce that VD minus is equal to VC plus 8. And we know that VC, what is the value of VC? It's to VB plus equals to minus 18. So now we can say that VD minus is minus 18 plus 8, so it's minus 10. So we have calculated that the shear at D minus is minus 10 kilonewton. And now, since at D we have an upward force of 10 kilonewton, this will lead to an upward jump in shear. So VD plus will be equal to VD minus plus 10, okay, because we have a concentrated force at D, so it's equal to 0. Minus 10 plus 10 equal to 0, okay. Let us continue. I will erase this to be able to continue. Okay, so until now we reached point D and we said that here the shear is V at D plus equals to 0. Okay, let us continue. Now, what will happen between D and E? If you want, we can draw in parallel the shear. يعني it's better each step to draw يعني between each 2 points to draw the diagram. Let us draw it and then continue. So to draw the shear diagram, I can take I have the x-axis. The x-axis will represent shear, and y-axis is x. So this is V function of x. Okay. I started first, as we said, at A. We said that VA is 0. So at A, I start with 0. Okay. From A to B, I have no load, so it's constant. So this is A. This is just before B. This is B minus. At B, what will happen? I have a downward jump. So I will go downward minus 18. So the value here was 0. Okay. And the value here is minus 18. Now, as we said, from B to C, also no change. So it will remain minus 18 until C. Okay. Now, from C to D, we said we have a linear increase until minus 10. So this is minus 10. We have a linear increase between C and D. So it's a straight line. And I should put some details here. I can say that the slope here, the slope of this line, I will put slopes in another color. So here, what is the slope phi equals 0 because it's a constant. Here I have the jump because of the concentrated force. Here again the slope is 0. Now, between C and D, I have a linear increase, and the slope is equal to W. W is 4 kilonewton per meter. So the slope here is plus 4. Now, at point D, I have a jump. So I have a jump to plus 10, from minus 10 to plus 10. So I have a jump until 0. Okay, so this is what we have done until now. To continue with our diagram, we say, what will happen now from D to E? Look, what will happen from D to E is exactly similar to what happened from C to D. Why? Because you have a rectangular load, and now you have an area equal to the area 1. So this is area 2, but this area is equal to area 1, since it's at the middle of the rectangle, equals to plus 8. Okay, so now I have a linear increase, and what is the slope? Also 4 kilonewton per meter. And now I will have a line parallel to this one. I have a slope of 4, and I'm moving up. Okay, I move up plus 8. I was 0 and I move up plus 8. So the value here will be plus 8. So I put here plus 8 kilonewton. And I say that this is linear. And what is my slope? Also here the slope is plus 4. And now I reached point E. So this is E. Finally.
بس
Yes, tell me.
ليش بلس 8
ليش plus 8 لأنه what is the change in shear delta V between D plus and E is equal from the course material to the area limited by the distributed load. What is the area limited by the distributed load? This area. How you calculate the area of this rectangle? It's the height. The height is 4 kilonewton per meter. And what is the width? It's the distance from D to E, which is 2 meters. Okay, so this is equal, delta V is plus, why plus? Because distributed load is upward. So plus area 2 equals to plus 8. And you can write that delta VD plus E is equal to shear at point E minus shear at D plus. And since we have demonstrated that V plus is 0, so we can deduce that what is the shear at E? The shear at E is 8 kilonewton. Okay? Clear?
Okay, thank you.
Okay. Now,
Here,
we still... Yes?
sorry, here plus 8 because the load is upward. The distributed load is
exactly.
upward. Okay.
Yes. If the distributed load is downward, we will put minus area. Okay? Like we did in class last time. Now, we still have the last part. The last part is the triangular load. Okay? You know that between E and F, what can we write? We can write between E and F, the distributed load is linear. The distributed load is linear. Okay, so how will be V if the distributed load is linear? V is what? It's a second degree parabola, because we said that V is integral W. So if W is first order, V will be second order. So V is a second degree parabola, and since W positive, then V will be increasing. Then V is increasing. Okay? This is about the variation. Now, if you want, in order to determine if the concavity is upward or downward, we should follow the slope. Okay? We should follow the slope. What do I mean by this? If we consider this is point E, okay, we are here. Now, at this point, what is the value of omega? This is your triangular load, okay? This is your triangular load. W is starting here by 4. It's 4 kilonewton meter at E, and is decreasing progressively. W is decreasing progressively until reaching at F a value of 0. And we know that this represents the slope of shear diagram. So if I go back to my shear diagram, at point E, what was the slope? 4 kilonewton per meter. So I put here a slope of plus 4. It's equal to the slope of the line here. So the slope here at the beginning was also plus 4. Okay? But now, from now on, what will happen? The slope will decrease. Okay? It will decrease until reaching at F. Yani when we reach point F, the slope will become equal to 0. So I will have a reduction in slope. The slope will decrease slowly until reaching at F a slope of 0. So if I want to draw my final part is a second degree parabola for which the concavity is downward. Okay, I have a downward concavity for my parabola because the slope was high and it decreased until reaching 0. So I can put here that my slope ends by 0. And I will put also that this is a second degree parabola. Second degree parabola. Okay. Now I still need one information to finish my shear diagram. I need to determine at this point here what is the value of my shear. To find the value of my shear at this point, I have two methods. The first one, I can say that since at the end of my beam I have a downward force of 14 kilonewton, this force will bring me back to, it should bring me back to 0. So what should be the final value of my shear? At this point, the shear should be plus 14. To make sure of this, okay, let us write what is delta V between E and F. Delta V between E and is equal to which area? It's equal to the area of the triangle. And it's a plus the area because also here the distributed load is upward. So if I consider this is area 3, delta V from E to F is equal to plus A3. And this area is equal to the triangular load, which is 3 times 4 over 2 equals to plus 6. And delta V between E and F is V at F minus V at E. Okay, so what can I say then? I can say that my my value of V at F, V at F is equal to 6 plus V at E, and we have calculated V at E to be 8, so 6 plus 8 equal to 14 as expected. So I verified that my work is right. Okay, any question until here? Okay. Second step will be to draw the moment diagram. So now I need to draw, I am done with shear. I want to draw the moment diagram. When I want to draw the moment diagram, I should look first if I have any couple on my figure. On my figure, I have one couple only, which is the couple at A. Okay, I just have a moment at A. Okay, so what will be my starting moment, my starting bending moment at A? You remember in class we said a clockwise moment will cause an upward jump of bending moment, while a counterclockwise moment will cause a downward jump. So since at A we have a clockwise moment equal to 2 kilonewton meter, we can write the following. We can say the bending moment at A is equal to plus 2 kilonewton meter. And what is the justification? Since we have a clockwise moment at A. Okay, this is the first step. Second step, I look at my shear diagram here. Okay, for my shear diagram, and B, what is V? V is equal to 0. If V is 0, so M is constant, because we know that since derivative of M with respect to X is equal to the shear, okay? Since between A and B, since between A and B, V equals 0, then the moment is constant, then the bending moment is constant between these 2 points. Okay, now what will happen suddenly now at B? Suddenly at B, the shear will become equal to minus 18. So now this is between A and B minus, okay? Now, between A and B plus, what can we say? Okay, between B plus and C, now between B plus and C, what is the value of shear? The shear is equal to minus 18. V equals to minus 18. Okay, so since V is negative, then the bending moment is decreasing. And since V is constant, the bending moment will be linear. So it will be decreasing in linear way. Okay, let us start to draw the diagram to understand how we can go through it step by step. So now I want to draw the bending moment diagram. Okay, we said at the beginning point we started by plus 2. So the value here was plus 2. And between A and B, V0, so the moment is constant. So we have first until point B, we have a straight line. Okay, now from B plus, okay, what do we have? To find the variation, we said that the variation is linear. But to find, if you want the final value of moment at C, what should we look at? We should look at the area limited by the shear diagram. If you look at this figure, from B to C, what do you have? You have a rectangle. You can name this area big one, area 1. Okay, and this is a rectangle. So to calculate this area, I just need to have the distance from B to C. This distance is 1 meter according to my figure here. Okay, this is 1 meter, and I multiply 1 by the height, which is 18. So I have 18. But since it's below the x-axis, so I should take minus the area. So I can say delta M between B plus and C is minus 18. And since my moment was plus 2, if I go downward 18, my figure is not to scale, of course, okay? So this is minus 18. And I will go in a linear way. So I will go in a linear way from plus 2. When I do minus 18, so this is 18 downward, I reach minus 16. So the shear will be at this point minus 16. So now I do a linear variation from plus 2 to minus 16. I just draw a straight line because the variation is linear. Okay, and now I reached point C. Now from C to D, okay, from C to D, what is happening? From C to D, my shear is linear. When my shear is linear, V is what? Sorry, my moment is what? We said
Is
that
parabolic?
Second degree.
very good. It's parabolic. Very good. So now the moment will be parabolic. And to draw the variation of the moment, I just need to represent the variation of slope. Okay? So now, after saying that this is linear, you can say what is the slope of this line? You just have to put a slope of, sorry, 1 second.
Minus 18.
Yes, minus 18, because the slope here is equal to V, equals to minus 18. So I just have to indicate here that this is a linear variation with a slope of minus 18.
دكتور
نعم.
ما كتير فهمت شو عملنا بالاريا بين البي والسي بالشير.
Okay. انت you have that dm by dx is V. So delta m, the variation in moment between 2 points, is integral v dx. What is integral v dx graphically? It is the area limited by the shear diagram. Okay? So here you need to consider this area. But why we take minus area? لأنه it's below the axis. يعني الانtegral will give you a negative result. So delta m between these 2 points is minus area limited by rectangle 1. Okay? And since the area is 18, so it's minus 18. And the value of m at point B was plus 2. If you do 2 minus 18, you get minus 16. So you deduce that the bending moment at this point, here at C, the bending moment is minus 60. Okay? Now, between C and D, what do we have? At point C, what is the slope, as you said? The slope was minus 18, okay? But now what is happening to the slope? The slope is increasing. It's increasing until reaching minus 10. And the slope is becoming إذا بدكم negative أقل من قبل. Okay? So if I illustrate this variation عم بيخف السلوب until reaching a value of -10. So إذا بدنا نرسم البارابولا if you want, the second degree parabola will have an upward concavity. It will have an upward concavity ليه؟ لأنه ليكو slope كان كتير قوي بالنيجاتيف and it's decreasing in negative direction. يعني the slope, the profile of variation is concave upward. Okay? So the concavity is upward, not downward. And this that this is a second degree parabola. Second degree parabola. Okay? Now, between C and D, what will happen?
نحسب
What will
الاريا.
happen? So already we said we have a second degree. بس شو بعد ناقصنا الاريا. We need to know what is the moment here at this point. Okay? To find the moment, the bending moment at D, we say that the variation, and now we can say that delta M between C and D, okay, is equal to minus area to, what is area to number 2? It is this area, هيدا اسمه trapezoid. This is a trapezoid.
بنقسمه
You can divide it
لريكتانجل
if you want. مزبوط. فينا نقسمه إذا ما بنعرف الفورمولا للاريا في trapezoid. We can divide this area into two parts, rectangle plus triangle. Okay, so we have first the area of the rectangle is 10 times the distance between C and D is 2 meters. يعني 10 times 2 عنا 20. The area 20 for the rectangle. For the triangle, you need to do base times height over 2. This distance here is the difference between 10 and 18 is 8. And you have here 2. So 8 times 2 over 2, it's 8. Okay, so in total, the total area here is 28. So I should say now I need to move downward between مثل ما قلت لكم الفيجر منا to scale. Okay, انتوا اكيد try to do it to scale as much as possible. مش حتزبط 100% يعني to scale, بس do it as much as possible to scale. So now I move downward. Okay, a value of 28, I will reach minus 44. Minus 44. So the minimum will be here. You know why this will be the minimum value? يعني ليش هون عنا minimum of 44؟ لأنه after D the shear will become positive. So since after D you have a positive shear, how will be the moment? It will increase. Okay? يعني the minimum value of your moment حتكون minus 44. Okay? خلينا so we are done with this part. Let us continue after D. What will happen? After D, okay, we'll have an increase in the moment. We'll have an increase first equal. هون عنا linear variation between D and E. We have a linear variation of shear. إذا shear is linear يعني moment second degree. What happened suddenly هلا? The slope was equal. We said at point D كان slope minus 10. فجأة صار السلوب هون 0. يعني we jumped from minus 10 to 0. يعني مرقنا بسلوب 0. وبيرجع also the slope now will increase from 0 until plus 8. Okay, since we have increase in slope, إذا بنرسم الvariation we have an increase in slope. Okay, يعني بعد concavity downward. And to know what is the value that we reached, what is the moment value reached, we need to calculate this area here, the area of this triangle. To get the area of this triangle, we know that the distance between E and E is 2, and the height here is 8. يعني 2 times 8 over 2. The area here is 8. يعني بدنا نعمل plus 8. So when we do plus 8, خليني أعمل لكم الفيجر to scale أكتر شوي. بدي أظبطها. يلا 1 second. Okay. So قلنا first we have linear variation until minus 16. Okay. رجعنا قلنا from minus 16 we have first a second degree parabola. تنعتبر لحديت minus 14. هحط minus 14 هون. Sorry, 44. Okay. So this is minus 44. لحديت هون. Okay. Now
دكتور
as
بس
we said
على الماينس 44 بيكون لسه عندها انه سلوب نيجاتيف وما هيك.
مظبوط. انت عندك نيجاتيف سلوب، بس فجأة شو بيصير السلوب؟ لاحظ كان السلوب minus 10 هون، يعني
Yes.
كان السلوب هون أول شيء minus 18 صح؟ The slope will
Yes.
be reduced to minus 10 هون، بيرجع فجأة شو بيصير السلوب؟ زيرو. ليه؟ لأنه طلع شو عندك upward jump من minus 10 ل 0. يعني the slope will suddenly vary from minus 10 to 0. يعني حيصير horizontal slope. اوكي.
يعني بيصير هيك
بيرجع
لثانية واحدة horizontal بيرجع بيكمل.
مظبوط، لأنه عندي jump in shear at point D. I have a jump in shear، يعني حروح فجأة من minus 18 ل 0 at the same point. Okay. Now from point D to E عندنا linear variation وقلنا plus 8. يعني نحن كنا minus 44. If we add 8, so if we add now 8.
دكتور مش 8 times 2.
8 times 2 over 2. ما هيدا triangle.
صح.
شو ال area of a triangle؟ 8 times 2 over 2 equals to 8. So now we'll have plus 8. Okay. يعني minus 44 plus 8 minus 36. حنطلع لحديت minus 36. وقد ايه السلوب هون؟ The slope at this point هون is plus 8. So now I have a slope of هلا بحط لكم قد ايه slope، وهون ال value of moment is minus 36. Okay. I will put the slopes with another color. فإذا كنا هون slope minus 18. رجعنا صرنا slope هون of 0. بيرجع عنا increase. صار slope at end هون at the end point at E صار 8. هلا أكيد we try to do the slopes to scale as much as possible. يعني أنتو جربوا شوفوا شو هن عندكم. الم 18 بده يكون أقوى سلوب. اوكي. وبيصير يخف شوي شوي، وهون بيرجع بيزيد لحديت 8. So we have a slope here of 8. Phi equals to 8 here. Okay. And now what do we still have? We still have the final variation from E to F. Okay. هلا عليكم from E to F it's complex. يعني the calculation of delta M from E to F is complex. That's why we will learn how to do it. But if you want to avoid calculation, you can say that F is the end of the beam. And because F is the end of the beam and at point F no couple, what should be the value of bending moment at the end?
0.
انتوا إذا ما عندكم 0, very good, 0. So we can say since at F, so at F you can say, okay. لحظة, 1 second. Okay. So M at point F is equal to 0 since no moment at point F. Okay, so you are sure that you should end by a moment of 0 at F. So you can put that at F I will end up by 0. Yani the final point should be here. Now to draw the profile of variation, okay, you need to look at the slope. What is happening to the slope? The slope is increasing from 8 to 14. Okay, so you will say that my slope will continue to increase and increase until reaching 0. Okay, and at the final point here, you can put that the slope phi is equal to plus 14. Okay, and then if you join your points, the profile will be like this until reaching F. And what is the type of parabola here? What is the type of parabola for
Power
the
3.
bending moment?
Power 3.
From E to F, it's
The power
second
of
degree or third degree?
third degree.
Power of 3. Very, very good. It's a third degree parabola. Why? Because between E and F, V is second degree parabola. And since M is the integral of V, so it's one order larger. So if V is second degree parabola, M is third degree parabola. And in this way, we have plotted the bending moment diagram M function of X. If you tell me I want to verify it's 0. I want to make sure of my calculations. Okay, how to do it? If I want to make sure of my calculations, I need to say that delta M between E and F, okay, is equal to this area here. The area limited by this parabola. This area. Okay, I will call it area number 3. So this is area 3. Okay. Now how to calculate area 3? So delta M from E to F equals to area 3. To be able to calculate this area, you need to know a mathematical formula. Okay, this mathematical formula is the following. If you have a parabola, a second degree parabola, okay, and you know this you can say that the parabola will divide a rectangular area, and if I extend these lines, I obtain a rectangle. The parabola will divide the rectangle into two areas. One from this side, okay, and one from the other side. The area that is here, yani the big area, is 2/3 of AB. Please, you have a condition for this. You need to have a slope of 0 here. If you don't have a slope of 0 at one of your points, at one of your extremities, or here, you cannot apply this formula. So, and this is satisfied here. This is satisfied here لأن هون slope is 0. Okay? So, or you do 2/3 AB for this part, or if you need this area, the small area, it will be 1/3 times AB. Now, since you are interested in this...
Can you repeat this formula, please?
Okay, yeah, I will repeat. If you have a parabolic shape, and at one of the points, at one of the extreme points, this one or this one, you have a slope of 0, you can say that the area of the big part is 2/3 AB, and the area of the small part, the other part of the rectangle, is 1/3 AB. How we can apply it here? If you look at your figure here, your parabola started from this point and it will end at f. At f, I have a slope of 0. So the condition of the formula here is satisfied. Yani I can calculate this area, this one, okay, as 2/3 of AB because it is the big area. small area ماني عايزها. It is the upper part. I don't need it. بينما لو concavity of your parabola is like this, يعني if you have 0 slope from this side, okay, you will have this part, this area will be 2/3 AB, okay, and the area below will be 1/3 AB here. This one will be 1/3 of AB. But here you are interested in the big area, اللي هي 2/3 of AB, because the concavity here is down and the 0 slope is at this point. So if you want to calculate this area here, you need to determine what is this height. This height is 14 because the end value of shear here, the shear will end at 14. And the shear at this point here is 8. So what is the height here? It's 14 minus 8. This height here is 6. So you can say that A is equal to 6. And what is B? B is this distance. This distance from the figure is 3. So in this problem, the area of your parabola is 2/3 times 6 times 3. You can see will out. So the area is 12. Okay. You have the rectangle. You have the rectangular part here. You should add the area of this rectangle. The area of this rectangle is 3 times this distance. This distance is 8. So 3 times 8 equals to 24. So what is the total area then? 24 plus 12 equals to 36. So this area 3 is equal to 36. Okay. And since this area is above the axis, so delta M is plus the area plus 36. So now I say the value was minus 36. If I do plus 36, I go back to 0. So this is verified. So my work is right. Okay. Any question on this?
دكتور نحن مسؤولين انه يكون عندنا مثلا مثل هون مثل اخر وحده اخر بارت اللي هو بقلبه انه third degree equation.
ايه مسؤولين اذا بس البارابولا اكيد بعطيك اياها هيك مع زيرو سلوب. اوكي. يعني انت فيك تعمل calculation وحتى كان فيك تقول بلا calculation I should end by 0 and you put 0 and you put it's a third degree parabola because V is second degree. بس ما راح يعني you are not responsible to find the equation تبعها بس لازم تعرف انها third degree parabola. اوكي.
اوكي دكتور هلا نحن ممكن مثلا نخلص وما نوصل لمومنت ايكوال 0؟
اكيد ممكن. اذا عندك حيلا calculation error وين ما كان بتطلع different than 0 ففيك تعرف انه عندك غلط. هلا it's fine you can say اذا ما لحقت تلاقي الغلطه it's not a problem. You can say I know it should end by 0 but I have some calculation mistake. يعني ما بيأثر. مهم تكون
بس
عارف
قصدي انه يعني اذا في body انه هو in equilibrium بيكون على طول
اذا في اكيد فيك ما تخلص بزيرو اذا في مومنت. يعني انت اذا على اف على البيم اوكي on your beam اذا عندي على الاند بوينت a couple ما بتخلص بزيرو. اكيد ما بتخلص بزيرو بس هون ما في couple at the end of the beam. نعم.
ويضل في equilibrium عادي كمان انه في يكون ما يخلص بزيرو يكون equilibrium طبيعي معك.
اكيد. ما انت اذا الكابل مثلا اذا انت بتخلص بكابل كاونتر كلوك وايز اوف 10 يعني اجباري الكاونتر كلوك وايز كابل بينزلك 10 فانت لازم تكون على الاخر بلس 10 بس تنزل 10 تصير 0. اوكي مثل ما عملنا
يعني
بالفورس بيفور نفس الكونسبت. So if you have a clockwise moment you should end by a negative moment. يعني إذا أنا عندي at the end of the beam a clockwise moment of 10 kilonewton meter I should end up by minus 10. إذا عندي at the end of beam a counterclockwise moment plus 10 لازم أخلص أنا ب plus 10 لأنه الكاونتر clockwise بينزلني نزول بينما الclockwise will bring me upward.
يعني هو
أوكي؟
مشان الايكوليبريم لازم انه اخر شيء المومنت الباندنج مومنت يروح المومنت اللي مفضل على اخر شيء.
مزبوط لازم ارجع لزيرو just after the beam.
اوكي.
Any other question? Okay, thank you. We're done for today.
Thank you.